Hello and welcome to another tutorial. You are welcome to AI with Siddharth, and we'll be talking about artificial intelligence and machine learning. Finally, I came to a topic which actually relates to my channel, AI with Siddharth. So without further ado, let's get on to this. So what is a machine learning or an artificial intelligence? But before understanding that artificial intelligence, let's understand the natural intelligence by the gift of Mother Nature. So, how we persons, or you can say how we humans, are able to recognize things. For example, a pen. I have a pen over here, a marker. How am I able to recognize this marker? Because I'm able to recognize this marker because when my brain sees this marker through my eyes, it actually makes several copies of a particular object. If next time if I see the same thing of that example, for example, I have another pen. Here it is. If I see this pen and this pen, I'm able to recognize between these two. I can differentiate between these two because my brain is able to recognize the points and the width and the height of this particular marker and actually compare those points with this marker. That's why we humans are a really great species and more intelligent than other animals. That's where we have difference. Yeah, cool. So, can we make the same intelligent machine, or can we bring the same intelligence to a software which can work like our brain, which can work exactly like us? Well, the answer is still hidden. Scientists are still trying to make a model, or you can say a software which works like that, but till now, if we talk about can we make a model which works like our human brain, then the answer can be changed. Yes, it is possible. So that's what we are going to discuss, machine learning. So, machine learning have three types. Actually, machine learning have three types. First is supervised learning. And learning. So what is a supervised learning? Actually, supervised learning is kind of a method where we train a model with some self-learning algorithm where model's answer, or you can say a prediction, is already being known. For example, I'll take a really simple example which we actually notice in our daily lives. An email spam filter. Okay, let's take two emails. I'm going to take email number 1, email number 2, and I'm going to denote this as not spam as NS, and this as spam as S. Now I can train a model, a machine learning model, which is a neural network, which looks like this. Yeah, I know it looks a bit creepy, but yeah, it's the thing. Sorry. And like this. We can train a model like this, a neural network, NN, artificial neural network, to actually identify that if the coming email is a spam email or not a spam email. But how does this neural network is able to recognize between these two? Actually, each emails are being labeled. For example, now not spam email is being labeled as not spam email, whereas spam email is being labeled as spam. And we give several number of label data of non-spam email and spam email, and feed those data to this kind of neural network. And once the data is given, we can write it in a simple algorithm like this, which actually every kind of machine learning models use to identify between the objects, or you can say between the two emails, which is we have training samples. I will denote the training samples as TS with the labels. We have this, Then we feed that into a predictive model, PM. Then we give a new data, ND, to that predictive model, and we get a prediction. That's how this thing works. And this classification task is also called as classification task, of course. We are classifying between two emails which is different from each other. Is it spam or not spam? Spam or not spam, yeah, correct. So, this was the first example of this, but we can say this as a binary classification. Binary classification where we have a number, where we have this as 1, we have a 0, and these data as not spam or spam is being recorded as binary classes. If the not spam comes, an email which is not spam labeled is 1, then it will go to a not spam category. And if the spam email comes and its binary classification is 0, it will go to spam category. So I hope you have understand that how does these two things differentiate in our mobiles, our Gmail apps, and also in internet. So let's see to another example, okay? I'll be back. Okay, so second example what we have is handwritten digit recognition. Sorry, I was not able to pronounce it properly. We'll do it again. Handwritten digit recognition. Okay, so for example, I have lots and lots of handwritten digit, and I want to classify if that digit is 6 or a 0. I'm confused a bit because some students write 6 as this. Maybe it seems to be 0. Some people write it clearly as this. Some write like this, which is clear, which is not clear at all, like this, and this. This is not to my senses. I can use a model which can actually differentiate between 0s and 6. How do I do that? So, sorry, excuse me. So, we can actually give him some data, data to a model which have few number of digit samples. Let's say 0, 6, 6, only sorry. We'll have two digits. We have two models. Okay, we have two data sheets. So let's do this. We have 6, 6, every kind of 6. Each and every kind of 6. Like we see in our digital board, our lift screen, it shows 6 like this. We have a few students who write 6 like B, 6 like this, like this, like this, or maybe like this, and so on. Okay, we have a digit, okay, and I have labeled this certain number of letters, which is, of course, the number of the digit. I'll say it as 6. I'll do it for each and every block. 6, 6, 6. Okay, cool. Now we have data. We can feed this data to a neural network, which I told you before, and whenever I will give a new data, which is any handwritten digit like 6, that digit will be recognized as 6 by the model, because we have what the model will do. It will actually compare this new data with the given labeled data, and this what we call this process a multi-classification task, multi-layer classification task, or where the models are being fed by labeled data and where the new data is not labeled. The model has to predict a label for a particular thing, particular data. So this was a handwritten digit thing. So we have a last thing, we have a last example of the same thing, but it is a binary classification task. As I told you in my spam or non-spam example, it relates the same. Let me show you one. I don't want to do it. Okay, so for example, I have a data sheet like this. Now I have a let's say plus, 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 and over here I have 0, or you can say minus, 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 and minuses. Only minus. So, I want to actually differentiate between these. So, a human can be able to do this by just drawing a simple line. But how a model will be able to do so? The answer is simple. What we will do is denote this thing as minus equals to 0, or let's take it as minus 1, or 0 must be good. Plus equals to plus 1, which is a plus. Okay, 1 equals to plus, 0 equals to minus. So, as we have this, we can feed this number of examples to a particular model to actually make a sense that this plus is actually 1, this minus is actually 0. And then we can program that model such a way to differentiate between these. If he see, for example, I'll give him new data. This is a label data, which I have fed that to a model, and this is a new data, ND. And the things are jumbled up. For example, minus over here, plus over here, plus, minus, 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 plus. So, what the model will do, a machine learning model, will do make a line such like this, which will actually differentiate between the minus and the plus. An imaginary line will be stretched out by a model. So these are the few examples of supervised learning where we actually know the answer, but our model needs to predict that known answer. Okay, so as we have cleared with the doubts of the supervised learning, we have cleared with the concept of supervised learning. Let's get on to the reinforcement learning. I'll be back in 2 minutes. I need to rub this board. I want to cut the camera, that's why. It makes boring. So, I'm back after erasing this all. We have second group of machine learning, which is reinforcement learning. Reinforcement learning. So, what is a reinforcement learning? Actually, reinforcement learning is derived version, you can say a subfield of supervised learning. It has been derived from supervised learning. What this does is, when in supervised learning, SL, we know the answer. Answer is Y. Sorry, the answer is no. To us. Okay, the answer is known to us. But in reinforcement learning, we don't know the answer, what the answer can be. But we can make some changes, or we can program in such a way, or we can improve his signals, improve his signal to make it better. To make his prediction more and more better. How do we do that? Or let's understand the concept of reinforcement learning first. Reinforcement learning is to improve the reward signal of the predicted results. Okay? So, I'm sorry. For example, we have reinforcement learning. Now, reinforcement learning have 5 steps to do. 5 steps to follow. We have an agent. Let's write it as agent. B, we have environment. We have an environment. C, we have a state. You can say, we have a state. D, we have reward signals. And the last is action. So, as the old label says, agent. For example, let's take a simple example of a Google autonomous car. If you have a car, okay, we have a car. I like the fancy cars, futuristic a bit. Yeah, we have a fancy car looking over here. Okay, this car will be your agent. An agent is in some environment. For example, a car is standing in a traffic signal and the signal is red. Signal is red and there are other cars waiting behind him or side of him. Okay? So this is our environment. And this, now, actually we'll first understand the state. Okay, actually reward should be the third one, but first we'll just talk about the state. Now this is the environment. What is the state of agent? Where is he standing? How is the behavior of other cars? How is the behavior of him? What is the color of the signal lights? That's the state. Now, reward signal. If this red light turns to green, and the car moves, that will be his reward. In short, it will give a plus point to himself that he has done the job, and the action will be he will go straight forward or to a particular direction he's programmed according to. Okay, so this was kind of confusing, right? Let me relate this example to real life basis. For example, you have completed you're in the final year of engineering examination, and you have got really good marks. Graded marks are really good, and you have got a job. You want to buy a bike or a car, and you actually ask your parents to please support me with at least 50% or not even 30% of financial help. I'll be able to buy the whole car. I like the car, that's why I took the example of car. So what your parents will say, yes, of course, my son, go ahead and do so. Because my marks is good, I got a job, and I just need 30% of financial help from my parents. So that will be a plus point, a reward point, which is a +1. So my action will be, of course, I will go to the bike. My agent, which is me, environment, my marks, environment, so actually have I passed or not, my other job thing, and my state. What is my state? Do I have a job? Do I have good marks? That's my state. Reward, if I ask my parents to please help me a bit, and they say yes, that will be my reward. Action will be to buy a bike or a car, whatever. Now we do an opposite thing to this, which is, okay, let's do an opposite thing to this, okay? For example, the agent, which is you, a failure student standing right behind over here. Just imagine that a student is standing right over here, this pen. And as this pen is the agent, the environment of this pen is he does not have a job. No, he does not. State is his marks are bad, he does not have a job, and he want a bike, not even a car, a bike. And he wants 30% of financial help from his parents. What do you think? The parents will allow him to buy a bike, or you know the answer. Parents will say, go to a hotel, work for a few hours, at least you'll get some money, then buy it by your own. That will be my negative reward. Yeah, that will be my negative reward, and my action will be what my parents says, or else this pen will be searching for his future. He will be intentional future. That will be his action. That's how the reinforcement learning works. The algorithm will be really straightforward. So, we have an environment. I will denote environment as E. I have an agent. Okay, the environment gives the state to an agent, which is S. The agent will give action to the environment, okay, and a reward signal will be given to the agent, which is +1 or -1. Any of these. Okay? That's how this is actually a concept of reinforcement learning. So, but whenever we train a model, we have some points where we need to describe, or you can say explain some of the variables. You know what those are things called? Those are called policies. Policies are nothing but behaviors. I want to rub this with my hand. It looks so good. See? I like this. Alright, enough talk, enough jokes apart. Let's concentrate over here. We have policy. Policy is nothing but state. And before policies, we have trial, or you can say episodes. Let's call this as trial. Now, for example, if I want to go from one state to other state, now this state, I literally mean a state. For example, India, I want to go from Maharashtra to Kolkata, Kolkata to Jammu Kashmir, then Jammu Kashmir to back to Punjab, then go back to Maharashtra. So, that is my state. I've performed some actions to perform a particular task from here to there, to travel from here, from point A to point B, then point B to point C, then D and E, and so on, till I've traveled. I'm tired after doing so much of travel. Let's do this. Okay, so we have a trial. Then after this trial, we have policy. I'm talking about the programming, okay? I've explained the real concept of reinforcement learning, but I'm actually clearing the doubts about programming. The programming, I may make a separate video about programming, but this series will only focus on concepts and theoretical knowledge. So, we have policy. Policy is denoted by behavior is the policy. As you know what the behavior is, I told you about the behavior. Behavior is actually denoted as pi. Now we have got into mathematics. If you like mathematics, if you don't like mathematics, no problem. This will make you love mathematics. Then in policies we have finite horizon. Now what is a finite horizon? A finite horizon is nothing but finite horizon actually maximize the reward signal to make a better prediction. As I told you, reinforcement learning concentrates that how the reward signal will be in such a way that how the prediction will be perfect. Okay, how the prediction will be perfect, and that